Hello students, this is Dr. JYOTI AGRAWAL. In the last lecture, we had discussed about orthogonality and orthonormality of a vector. Today, we will discuss about Gram-Shimdt orthogonalization. So let's start. Let's move to the next slide. So let us suppose that B is a basis. Then we earlier we had studied that the vectors of basis are linearly independent. Also V equals to span of B. We know that these things. Now first of all we convert B to orthogonal set B dash. Also span of B dash equals to span of B. We have to prove these two things. Then basis is said to be orthogonal basis. If these two conditions are satisfied, then we say that basis is the orthogonal basis, which means we can say that if we have to prove that this basis is a orthogonal basis, for this first of all we convert it to orthogonal set B dash. Also span of B dash equals to span of B. Then this basis is said to be orthogonal basis. This process is known as Gram-Shimdt orthogonalization process. In this process B, let us suppose that B equals to W1, W2 and so on Wn, that is a set of n tuple and where W1, W2, Wn are vectors. Also suppose B dash equals to any set V1, V2, V3 and so on Vn, and let us suppose that V1 equals to W1 and V2 equals to W2 minus inner product of W2 and V1 upon inner product of V1 and V1 into V1, that is V2 equals to this one. Similarly, V3 equals to W3 minus inner product of W3 with V1 upon norm of V1 ka square into V1 minus inner product of W3 minus V2 upon norm of V2 ka square into V2. Similarly, this process continues. So we can write V4 equals to W4 minus summation I equals to 1 to 3 inner product of W4 with Vi upon norm of Vi ka square into Vi. This process is known as Gram-Shimdt orthogonalization. Let's move to the next slide. If we have to convert the orthogonal basis into orthogonal basis B dash, for that we divide each vector by its norm, that it becomes orthonormal basis. अगर हमें किसी orthogonal basis को किसी orthonormal basis में convert करना है तो इसके हर एक वेक्टर को उसके norm से divide करते हैं. So if U1 equals to pair 1 1 and U2 equals to the ordered pair 1 1 2 and 4 and U3 is the vector this one, then find the orthonormal basis. In this question we have to find the orthonormal basis. So first of all, for the orthonormal basis, let us suppose that any vector V1 equals to U1, which is given as this one. So by using Gram-Shimdt orthogonalization, let V2 equals to U2 minus inner product of U2 with V1 upon norm of V1 ka square into V1. Now if we solve it, then we can write in place of U2 given vector 1 1 2 and 4, and inner product of U2 and V1 means dot product of V1 with U2, we get 1 plus 1 plus 2 plus 4 upon में norm of V1 का square मतलब 1 का square plus 1 का square plus 1 का square and plus 1 का square, we get 4 and V1 equals to 1 1 1 and 1. If we solve it, then we get minus 1 0 and 2. Now here norm of V1 का square equals to 2. Let's move to the next slide. Again vector V3 we can write it as U3 minus inner product of U3 with V1 upon norm of V1 का square into V1 minus inner product product of u3 with v2 upon norm of v2 chi square into v2. Here norm of v2 chi square equals to 6. Now again putting all these values, then we get in place of u3 we put 1 2 minus 4 minus 3. Again inner product of u3 with v1 means dot product of u3 with v1, then we get 1 plus 2 minus 4 minus 3 upon 4, and in place of v1 we put 1 1 1 and 1. Similarly, we put all the quantities in the third term. Then we get, after some calculation, 1, 2, minus 4, minus 3, 1, 1, 1, 1, plus 3 by 2, this one. Then we get this pair 1 by 2, 3 by 2, minus 3 and 1, where norm of V3 equals to 5 upon root 2. Now the orthonormal basis is obtained by dividing each vector with its norm. Then we can say that v1 upon norm of v1, v2 upon norm of v2 and v3 upon norm of v3. If we put all these values in it, then we get the orthonormal basis. Let's move to the next slide. Now let us discuss an example, which is the orthonormalize the set of linearly independent vectors. Here we have to orthonormalize the set of vectors, this one. Here vector v1 equals to this one, v2 equals to this one and v3 equals to this one. Now if we take norm of v1 chi square, then we get 2. So now we use the Gramshift orthonormalization. So let u1 vector equals to vector v1 upon norm of v1, then we get this one. We get this one. Similarly, now let w2 equals to v2 minus inner product of v2 with u1 into u1. Now if we calculate inner product of v2 with u1, then we get 0. So we can say that vector w2 equals to pair 1 0 minus 1 minus 0 into this one, which means 1 0 minus 1. Similarly, we can find norm of w2 chi square equals to 2, and again u2 equals to w2 upon norm of w2. Then we get 1 upon root 2, 0 and minus 1 upon root 2. Let's move to the next slide. Again take w3 equals to this one, then we have inner product of v3 with u1, inner product of 0 3 4 and 1 by root 2, 0 and 1 by root 2. If we solve it, then we get this one. Similarly, if we take the inner product of v3 with u2, then we get minus 2 root 2. Again w3 equals to this one. Thank you students. After that we will discuss some more topics in the next lecture. Thank you.